Okay guys, I welcome you all to my channel Engineers Academy. Now we are going to solve these problems from Thomas Finney calculus, and the problem says that plot the points in exercise 9 to 12 and find the slope if any of the line they determine. Also find the common slope if any of the lines perpendicular to line AB. So first we are going to solve this problem 9. So there are 2 points in problem 9, that is point A is -1, 2 and point B is -2 and -1. So first of all, I'm going to plot that point A. So point A is x is -1, so this is -1, and then +2 in the y direction. So the A point lies somewhere here. So this is the location of point A, and then for point B the x coordinate is -2, so this is -2 and then -1. So point B lies somewhere here. So this is somewhere here is point B. So now if I join point A with B, so this will be that line which is going to pass through these 2 points, and we are going to find the slope since this line has some slope. So the slope is always equal to the rise divided by run. So the rise is change in y coordinate, so the change in y coordinate will be the y coordinate of B minus the y coordinate of A. So that is -1 minus the y coordinate of A, and change in x will be the y coordinate of the x coordinate of B minus the x coordinate of A. So this is equal to -3 divided by -2 plus 1, which gives us -3 divided by -1, and minus will cancel out, so we will be left with 3 divided by 1. And as we can find the slope directly if we plot point A and B and join point A and B. So as we can see that for 1 units in x, for 1 unit change in x, the change in y is 1, 2 and 3. So for 1 unit change in x, there is a positive change of 3 in the y direction. So this is the slope of that line. And now the line which will be perpendicular to this line will be, as we know that if you want to find the slope of a line which should be perpendicular to this AB line, which is represented by these 2 points, so then as we know that the slope of perpendicular line, the product of the slope of the perpendicular lines is always equal to -1. So now let's say that this line is, let's say, line 1. So the slope of line 1 and the slope of perpendicular line to this particular line will be, the product of that will be equal to -1. So the slope of the perpendicular line will be equal to -1 divided by m1. So this is our m1, and now we can write that the slope of the perpendicular line to this particular line will be equal to -1 divided by 3 divided by 1, or we can say that perpendicular slope will be equal to -3. So the reciprocal of this, the negative reciprocal of this, will be the slope of the perpendicular line. Now the next problem is this problem 10, which again we have 2 points. So now let's plot those 2 points for problem exercise 10. So the first point is -2 and -1. So again the x coordinate is -2 and +1, -2 and +1. So this is -2 and +1. So we have the point A somewhere here. This is point A for problem 10, and then point B is 2 and -2. So the x coordinate is +2, this is +2, and then -2. So point B is somewhere here, right? So let me plot that. So this is point B. Now if we join both of these, so that will give us that line which is represented by these 2 points. Let's say this line is represented by its name L2. So now again for problem 10, we can find the slope. So the slope will be, again, let's say that will be equal to the rise divided by the run, the change in y divided by change in x. Now we can find the slope directly from this graph. So the change in x is in the negative direction, right? So from 1, 2, 3, 4. So for 4 steps in the negative x, we have 1, 2 and 3. So we have 3 positive steps in the y. So we can write it directly, that is plus 3 divided by minus 4. So the slope of this line is we can say that the slope is minus 3 divided by 4. And now let's find it by that formula. If we find the slope by change in y and change in x, so that will be m, let's say. And now the change in y will be this minus 2 minus 1. So minus 2 minus 1 divided by the change in x. The change in x will be 2 minus minus 2. So that is 2. Let me write 2 and minus 2. So this gives me minus 3. So this gives us minus 3, and 2 minus minus 2 will give us plus 4. So we get that same slope, that is minus 3 divided by 4. Now if this is the slope of that line 2, if this is line 2, so let's say this slope is represented by m2. This is m2. And now if you want to find the slope of the perpendicular line to this L2, so then that perpendicular line slope will be equal to the negative reciprocal of that m2. So this will be equal to minus 1 divided by minus 3 divided by 4. So this will give us plus 4 divided by 3. So this is the slope of the perpendicular line to this line 2, which is represented by this pink line. Now the next problem is problem 11. Again we are given 2 points. Point A is 2, 3, and point B is minus 1, 3. So if we plot these points, the coordinates of point A are plus 2 and 3. So plus 2 and plus 3. So point A is somewhere here. This is plus 2 and 3. So this is point A. And point B is minus 1. So this is minus 1 and plus 3. So somewhere here. So this is point B. So if we join these 2 points, so this represents a horizontal line, and the slope of the horizontal line is 0, and we can confirm it if we find the slope by change in y divided by change in x. So change in y will be this 3 minus 3, so this is 0. So 3 minus 3 is 0, and minus 1 minus 2 is minus 3, but 0 divided by anything will give us 0. So the slope is 0, right? So this is minus 3, so this gives us 0. So the slope is 0. And now if you want to find the slope of a line which should be perpendicular to this, so that will be again equal to the negative reciprocal of the slope of that line. So this will be equal to minus, and if the line is perpendicular to a horizontal line, its slope is directly equal to undefined, right? So that is, if we take the reciprocal of this, so this will be minus 3 divided by 0, and that will give us undefined. Now the problem 12 is for problem 12, the point A and B are these two. So A is minus 2 and 0, and B is minus 2 and minus 2. So now if we plot these 2 points, point A is at minus 2, x is minus 2 and 0. So point A is lying on the x-axis, so it is somewhere here. This is point A location, and point B is minus 2 and then minus 2, so somewhere here. So this represents a vertical line. So now if I join these 2 points, so we will have this vertical line, and since it's a vertical line, so its slope will be undefined. And the slope of a line which should be perpendicular to this line will be the negative reciprocal of that, and that will be a horizontal line, so that the slope of that horizontal line is 0. Now we are going to solve this problem from 13 to 16, which says that find an equation for a vertical line and the horizontal line through the given point. So in problem 13, the given point is minus 1, 4 divided by 3, and we have to find the equation for the vertical line. and for B for the horizontal line. So we can say that for vertical line the slope is equal to, let's say, undefined, or we can say that this is 1 divided by 0. And similarly for horizontal line the slope is equal to 0, or we can say that this is 0 divided by 1. So this gives us 0 and this gives us undefined. Now we are going to use the point slope equation. So the point slope equation is y minus y1 equals to m into x minus x1. So this is the point slope equation that you already know. And now this point is given, so this is x1 and y1 coordinate. So now we need to put this x1 and y1 in this equation, this point slope equation. So we will have y minus y1 is 4 divided by 3, and the slope for part A is 1 divided by 0, and x minus x1, so x1 is minus 1. This is our x1. So now if we cross multiply the slope, if I multiply both sides of equation by 0, so the left hand side will become 0, and we will be left with this 1 into x plus 1. So from this x equals to minus 1. So this is the equation of a vertical line which is passing through this point. Similarly for horizontal line, again we have to use the point slope equation, which is m into x minus x1. Now the slope is 0 divided by 1, so we can write that y minus 4 divided by 3, y1 is 4 divided by 3 again, and the slope is 0 divided by 1, x minus x1, and x1 is 4 divided by 3, so we have to write that this is 4 divided by 3. Now if I multiply both sides of equation by 1, so this 0 divided by 1 is 0, right? Basically this slope is 0. So now let me write this as 0. So this is 0, and the right hand side of the equation will become 0, so we will be left with y minus 4 divided by 3. This is equal to 0, and y is equal to 4 divided by 3 is the equation of the line which is horizontal and passing through this given point. So now the problem 14. The given point is x1 and y1. This is equal to square root 2 and minus 1.3. Again we are using the point slope equation. So we have y minus y1. So y1 is minus 1.3. And for part A, the slope is 1 divided by 0, so I will write 1 divided by 0, and then x minus x1, so x1 is square root 2. So this, if we again multiply both sides of equation by 0, so this will be cancelled out, and the left hand side will become 0, so this will be equal to 0, and this is x minus square root 2. So x will be equal to square root 2, and this is the equation of the vertical line which is passing through this point. And similarly again, if we write the point slope equation, so y minus y1 is again minus 1.3, and for horizontal line the slope is 0, and x minus x1. So now the right hand side will become 0, so this will be y plus 1.3, and this is equal to 0, so this is equal to y is equal to minus 1.3. so this is the equation of the line of the horizontal line having slope equals to 0.